Hi everyone, and welcome to our next lesson. Why don't you guys make sure you have your calculators out for this lesson, because we're going to use them quite extensively. At the very top of your notes it says we're solving quadratic equations by graphing. So we're going to use our calculators to graph each equation to find the roots. To let you guys know that whenever we find roots, it's the exact same thing as when I say find the solution, find the zeros of the function. They all mean the exact same thing. So find where it crosses the x-axis. We're going to do that today using our graphing calculators. We're first going to estimate where that is, and then we're going to use our calculator to find out exactly where that is on the table on our calculator. So here's the first one. We're going to put this into our graphing calculator. So x squared plus 6x plus 8 equals 0. We're just going to set this equal to y. So y equals x squared plus 6x plus 8. So let's go to our calculator and enter that in. So right here, top left button is y equals. So y equals, and let's enter in our information. X squared, the x button is right below mode, right next to alpha. So x squared plus 6x plus 8. Now hopefully you could see right now before we press graph, it's going to be a parabola because our degree is squared. Our degree is 2. And we know it's a parabola that's going to go up because we have a positive a value. It's 1x squared. So a positive a value is going to say it opens up. So before we even press graph, we can kind of see that in our head. So now we're going to press graph, that top right hand button. And there is a picture of our parabola. So when we look at this, it says solve or find the roots of this equation. We're going to do that in the table, but first let's just estimate. Here is our origin, 0, 0, where that red dot is. So if I look, where does it look like it crosses the x-axis? It looks like it crosses at a -2, and it looks like it crosses at a -4. So let's use these estimations to check our work as we go through with our table. So to find the table, instead of press graph, press second graph, because that's where the table is located. So second table. Okay, it appeared to us that our x values were at a -4 and a -2. Now the zeros of a function class, if you look at this again, the zeros of our function is when our y-axis, when our y-coordinate is 0. When it goes up and down 0, how far left and right does it go? So we're looking for our calculator on when is our y-coordinate 0. That's where our root is, or that's where our solution is. We record that value for x. So where in our table is our y-coordinate 0? So now go to the table again. We thought it was at a -2. Let's see if we are right. At a -2. Oh, press too many times. There we go. So at a -2, we do indeed get a 0 right there, don't we? A -2, 0. And our other 0 is right where we thought it would be. It's at a -4. So a -2, 0, and at a -4, 0. Those are our roots for this. We found that by using our graphing calculator and by approximating. So x equals a -2, and x equals a -4. We could have got that by factoring as well, but now we just have another tool in using our graphing calculator. Let's now try doing this again for problem number 2. Looking at number 2, I want to get a 0 on the right side of my equation, so let's add this 4 over. So putting it in descending order, it's x squared minus 4x plus 4 equals 0. And then I guess when we put it into our graphing calculator, it's going to be y equals that. So let's put this into our y equals equation. So let's go back to our calculator. Y equals, we can clear what is ever in our calculator so it doesn't confuse us, so just press the clear button. Y equals x squared minus 4x plus 4. X squared minus 4x plus 4. We graph this. It's going to be a parabola. It's going to open up again. There we are. So our solution is where it crosses the x-axis. This one is a little bit trickier than the last one. It looks like it maybe crosses at that spot, which looks like a +2. but we should get two answers for these. So does it cross at 1.9 and 3.1, or what happens with this? We're going to take a look by looking at the table. So go second table. Let's again find where our y coordinate is 0, and we're going to record our x coordinate at that point. So when y is 0, that is found at this spot right there, at 2, 0. Now notice, I don't have any more y coordinates that are 0. If I go up, I start to see 1, 4, 9, 16, 25, 36, 49, 64. I'm getting bigger and bigger and bigger as I scroll up on my calculator, and as I scroll down, I go from 1, 4, 9, 16, 25, 36, 49. So I'm getting bigger and bigger and bigger when I scroll down as well. So I only have one coordinate where my y coordinate is 0. That's when x equals 2. So my answer here on this problem is x equals 2. But whenever I get an x squared term, it means I need to have two answers for x. So what does that mean, class? That means that this is a double root. X equals 2 is a double root, which means instead of crossing the x-axis, it hits the x-axis, and then it goes back up again. So it goes down and down and down and down, hits the x-axis at 2 before it goes back up again. So that's the answer to that problem. Here's the last one, number 3. It's already in standard form for us, so let's put this in our graphing calculator, x squared minus 4x plus 5. So under y equals, clear whatever we had in there, and put in there x squared minus 4x plus 5. When we graph this one, our parabola, boy, it doesn't even look like it crosses the x-axis, does it? I don't see it. It gets close to the x-axis, but I don't see that it touches it. If we look at our table here, when is it going to reach, when is our y coordinate going to be 0? So if we start up here, okay, so it's at 50, 65, 50, 37, 26. So it's getting lower and lower and lower. We're getting closer to 0. It goes 2 and then 1. Oh, but now it starts increasing again. It's not getting to 0. Now it goes 2, 5, 10, 17, 26. So the closest we got to 0 was this point right here at 2, 1. But that still isn't a solution. So on this one, class, it doesn't hit the x-axis. There are no real roots on this one. So for this one, we put no real roots. So if there's no real roots, what kind of roots do we have? They are imaginary roots. So this is going to have an I in our answer. We're going to learn more about that as we go further on with this chapter. But for now, if it doesn't cross the x-axis, I just want you to put there's no real roots. Let me know if you have any questions on those three problems when you get to class tomorrow.